in white and cross-veinless was 14. Right? So 14 is close to 13. Correct? These are approximate numbers that you're working with. So 14 is close to 13. So what's the correct map? It's most likely this one. Okay? So it's a simple two-dimensional puzzle of kind of pieces of string, different length strings. One that's 20 units long, one that's 14 units long, one that's 7 units long. How do you fit the three together to build a single map? Well, 14 plus 7 is very close to 20, and so that's
If it were the
top one.
and the distance between W and C was greater than 50, would it still consider
We'll
the
come to that. Hold on. Very good question. Okay. So by determining distance between white and cross-veinless and the map distance between cross-veinless and singed, we can determine distance and the order of all three genes. Taking that example of a car breaking down. I told you the car breaks down on average 7 times between San Francisco and Santa Cruz. And it breaks down, so you have a little table, and you say, Santa Cruz, San Francisco, 7 breakdowns. Santa Cruz, Monterey, 4 breakdowns. And you measure the number of times a car breaks down between between San Francisco and Monterey, and it's 11 breakdowns. Now you have to put it all together in a single piece, in a single puzzle. Well, you have 11 between San Francisco and Monterey, 7 between San Francisco and Santa Cruz, and 4 between Santa Cruz and Monterey. And you have only one way in which you can put them together. Right? So that's all you're doing, in fact, when you're mapping 3 different things. It's a two-dimensional puzzle that you kind of fit together. Okay. So which map is consistent? Well, the most consistent map, the closest to being consistent map, is basically this one. And so there is a small internal inconsistency. Anybody have an idea about why this internal inconsistency happens? Why is it 14 and 7, not 16 or 14 and 6 or 13 and 7? Why is there a small difference? What's happening? Why are you having a small difference? To come to that, it's because of double crossings. As you go further and further along, you have a greater probability of having 2 crossings instead of 1. When you have those, they'll look like the parents. And so you will undercount your recombinant cross. And because of that, the value is slightly wrong. Okay. The map gives you a very particular order of genes. And we found that to be true for pretty much even after the sequencing of the human genome and the Drosophila genome, etc. The order of the genes are very accurate with regards to how they determine them using crossovers. The distances are not precise. They are close but different. Okay, so here's the genetic map. And this comes to your question. Okay? So here are different genes along the chromosome in Drosophila. You have skewed bristles, echinus eye, cross-veinless, cut wings, vermilion eyes, garnet eyes, and fork. So you have a whole series of different mutants. And you carry out multiple 2-point crosses, right? You're crossing skewed with echinus. You measure the combination frequency, and you find it's 9.1 mappings. Cross of echinus with cross-veinless, and you get 10.5 mappings. You then do a cross, just like the ones I showed you, between cross-veinless and cut, and you get 9.2 mappings. Then you do cut and vermilion, you get 15.9 mappings. You do vermilion and garnet, you get 11.2 mappings. And then you do the last cross between garnet and fork, and you get 10.9 mappings. Okay? So you've mapped these different genes along the chromosome, along the X chromosome, a whole slew of different genes. Right. Now, what happens if you were to do a cross between skewed bristles and forked bristles? What would the distance be? Well, Let's add them up. 9.1 plus 10.5 plus 9.2 plus 15.9 plus 11.2 plus 10.9. What's the value? Anybody who whiz at maths at 8 o'clock in the morning? It's 66.8 microns. Correct? So if you were to do a cross looking at just skewed bristles and forked bristles, what would be the recombination frequency? 66.8%? No, I just told you you cannot get more than 50% recombination frequency. So when you do the analysis between skewed and forked, the value you would get would be 50 microns. And 50 microns also means that two genes are not linked. Right? So you reach a conclusion that when two genes are on the same chromosome but very, very far apart, they will appear unlinked. Because they will give you a value of 50 microns. And that is basically the same as saying they are unlinked genes. They cannot be 66.8. You just cannot get that. What you get is 50. When you get 50, you automatically say they're unlinked, even if they are linked. The only way you will find out that they are linked is by doing a cross between skewed and cut, and then cut and fork. Then you'll be able to determine whether they are actually linked. Okay? Answer your question? All right. So, any questions on this aspect of mapping genes? Okay. Let's continue with the next lecture. I'll tell you at what point things will not show up in the midterm in a very short time. We're not going to have 3-point crosses in the midterm. Don't smile.